This video is over lesson 97, graphing linear inequalities, and it is for my Algebra 1 class. So ladies and gentlemen, first of all we start off with a vocab term which really shouldn't be a surprise to us by this point because we've talked about what it means to be a solution to an equation, we've talked about what it means to be a solution to an inequality in general. So now the solution to a linear inequality is very similar. And since this is a vocab term, let's go ahead and highlight that in yellow. So when we say a linear inequality, so what this suggests is that if we were to graph it out, we would be graphing a line. So this is going to have to do with two variables instead of just one. So a solution to a linear inequality is any ordered pair, so a pair of x value with a y value, that makes the inequality true. So ladies and gentlemen, to help us out with this today, we are going to go ahead and take a look at the practice problems from the book. So if you'd please write practice. And we're going to start with letter A. So letter A says, determine if each ordered pair is a solution to the given inequality. And so in our work, I'm going to ask you to start by copying down the equation, or the inequality, excuse me. So y is greater than 3x minus 2. So you'll do that in the homework. Now I'm not going to have you copy down the point. Instead, what we're going to do is the next step of our work is going to plug in the values of the point. So the y value of the point we're checking is 6, and then it's greater than 3 times the x value is 2, and since it's not a negative, the dot works nicely there, and then minus 2. And so I can see here that you have your inequality, and then I can see that it must be the ordered pair 2, 6. And so we've copied both the equation and essentially copied the point. And now we simplify. So 6 would be greater than 6 minus 2. So 6 is greater than 4. So is that true? Yes. So therefore is 2, 6 a solution to this? Yes, it is. Moving along to B. So B, likewise, I'm going to copy down my inequality. Y is less than a negative 4x plus 1. And then my y value is 1. And then I have a negative 4 times my x value of 4 plus 1. So negative 4 times 4 would be a negative 16. And then negative 16 plus 1 would be a negative 15. So is a net 1 less than a negative 15? Well, no, it's not. So this has been wrong ever since I plugged those values in. This top inequality here is correct. It's still true because we can find values where that would be true. However, 4, 1 does not make this true. So therefore this is a no. C. Y is less than or equal to 5. And so we're checking the point negative 6, 2. And this isn't really quite easy. So we have a y value here where I plug in 2. But then I have nowhere to plug my x value in, which tells us really here that the x value doesn't matter. It really doesn't matter. And so I still have my 5 there. So is this true that 2 is less than or equal to 5? Yes, it is. So actually for this one, there was nowhere where we copied down that negative 6. And that's actually okay, because it doesn't matter what the x value is. So what we've proven here is that as long as the y value is 2, this works. As long as the y value is 2, it's a solution. So x could be negative 6, x could be positive 6, x could be 293.7. It doesn't matter what x is, only the y mattered here. And so that's good enough for letter C. Moving on to D, now we're going to look at graphing the inequalities. So when I go to graph these, we need to remember what it's like to graph with just one variable. So I'm going to actually take a look at my dry erase board here for just a quick second. And let's say we had x is greater than 4. Well, essentially, my 4 here is going to act like a boundary between the solutions and the things that are not solutions. So since there's only one variable, we only need one axis. We'll put our boundary in the middle here. And so then I'll have a 5 and a 6 over here. I'll have a 3 and a 2 over there. And since it is greater than, this will be an open dot. It's not included in the solutions. And then we just figure out, okay, which side should the solutions be on? Well, is 3 greater than 4? Or is 5 greater than 4? Well, 5 is. So the solutions must be in the direction of 4. So this number over here acts as our boundary. On the other hand, if I had x was less than or equal to a -1, this time my boundary is going to be that -1. So when I graph this, we normally stick our boundary in the middle. Don't have to, but we normally do. And since it has the option of or equal to, that means that -1 is included as one of the solutions. So therefore the dot gets filled in, we get a closed dot. And so then we consider, is -2 less than or equal to -1, or is 0 less than or equal to -1? Well, obviously it's -2, so therefore the solutions must be on this side of the boundary. So when it comes to graphing linear inequalities, and I'm sorry, I should have said linear inequalities, my mistake. So let's fill that in, linear inequalities. So graphing linear inequalities, graph as if it were an equation. So if you take your inequality and you graph it as if it were an equation, that's going to give you your boundary line. So whereas over here we had a boundary number, now we're going to have a boundary line that will separate solutions from non-solutions. So quick note here, a greater than and less than will be, well, just like here, my greater than was an open dot, meaning that it was not included. Well, if it's one of these, it means that our line will not be included. So if the line is not included, then it will be a dashed line. Dashed line. If it is greater than or equal to, or less than or equal to, so those two, greater than or equal to and less than or equal to, will be a solid line. And so it'll be all the way filled in, just like our closed dot was all the way filled in. So that's the first thing, what we got our boundary. So step 2, test a point not on the boundary. Often a good point to choose will be the origin. As long as your boundary line doesn't go through the origin, that's often a nice point to choose because turning things into zeros makes them real easy. Okay. 3, shade the side with the solutions. So if our test point works, then we know that that side of the line has the solutions. Shade that side of the line. If our test point does not work, shade the other side of the line. The solutions must be on the other side. So with that being said, we're going to move straight into D now. And I know I don't have a ton of room, but we're going to try to make this work here. So for D, we have 4x plus 5y is greater than or equal to negative 10. And you've got a couple options here when you look at this one, because you could solve this basically into slope-intercept form. In general, I think that would be easiest. Right now, it's in a form that we would call standard form, which, if you remember standard form is nice for finding your intercepts. So you really could go either way. So if I plug in 0 for y, I can solve that to find my x-intercept. If I plug in 0 for x, I can solve that to find my y-intercept. There's 2 points and you've got your line. But generally speaking, it's usually easier if we just go ahead and solve that for y. So if I solve this for y, negative 4x on both sides, so 5y, oh, not equals, sorry, force of habit, is greater than or equal to, because subtraction does not change my inequality, to a negative 4x plus 10. Divide both sides by 5. Don't forget that it's the whole side that you're dividing by 5. So then y is greater than or equal to a negative 4/5 x. So I'm going to let that x fall off the side of that fraction. Plus, and then 10 divided by 5 would be 2. So if I go to graph this now, I don't have a ton of space here, but I'm going to make it work. And you want to make sure that your tick marks are as evenly spaced as possible. A little bit of human error will happen, but as much as possible. Now I'm looking at what I did here. If you look at how far away that is versus how far away that is, these are just too spaced out. So I realized my mistake. Human error happens. Even I have moments like that. So I'm just going to come in here and fix that up a little bit. And even then, I think I can get that one a little better. All right, so that's pretty good. Now, since I have such a little bit of space here, I've got to consider what's my scale. Can I go by ones? So we know we're going to have an intercept of 2, but then we have to go down 4 and right 5. I think I can fit that in. So I've got my 2 for my y-intercept, and I'm going to go down 4 and right 5. So 1, 2, 3, 4 down, 1, 2, 3, 4, 5 to the right. And then I'm going to reverse it and go up 1, 2, 3, 4, and then 1, 2, 3, 4, 5 to the left. Make sure that's nice and lined up. And so then I'm going to connect those dots. Now remember though, what kind of boundary do we have? Since this is a greater than or equal to, it'll be a solid line. So my boundary this time is going to be a solid line. And so then we just need a test point. So my test point might be the origin, since this doesn't go through the origin. So we're basically asking, does 0, 0 work here? So 4 times 0 plus 5 times 0 is greater than or equal to 10. So 4 times 0 is 0, 5 times 0 is 0, and all that's basically 0. So 0 greater than or equal to 10? Well, obviously not. So, therefore, the solutions must be above the line. So on the other side of the line there. And so we shade it in kind of like that. So don't go too crazy. We still want to see the coordinate plane and all. And ladies and gentlemen, you might have heard the pause in my voice for just a moment, because I was looking back at my book and things weren't quite looking right. And I just realized my mistake. I made this a positive 10 instead of a negative 10 in the book. It doesn't matter. We're going to go with the positive 10 since that's what I've just done and I'm not redoing it. But if it had just been a negative 10, the only difference would have been that this would have been a negative 10. That would have been a minus 10, so this would have been a minus 2. And so all it would have done is just shifted this down to a y-intercept of negative 2. So it wouldn't have affected anything in our answer other than just shifting this all down. So there it is. All right, we're going to look at E. I'm going to have to go to the back because I am out of space. So E, I have x is less than 6. So I am going to at least copy that down so we know what we're graphing. Now when it comes to a number equals, or excuse me, x equals a number, you have to think about that as the x value always has to be that, but since y is not here, y could be anything. Well, if y can be anything, then you're talking about something that can go up and down wherever it wants to, but it always has to have the same x value. So this is going to be a vertical line for our boundary. So x equals a number would be a vertical line, y equals a number would be a horizontal line. So our boundary will be vertical. All right, so let's do this. I'm going to make my coordinate plane. And I'm going to go 1, 2, 3. I'm just going to use the half spaces there. And I'm going to try to space this out about as evenly as possible. And then I'm going to give this a scale of 2. So I don't have to go out so far. So this is going to be a vertical line where all of the x values go through 6. But remember, because this is a less thans produce a dashed line. So it's going to be a dashed line. Still has the arrowheads. It's going to be a dashed line through 6. So this tells me that the boundary is not part of my solution. So choose a test point. Again, the origin can be kind of a nice test point here. So 0, 0. Does it work? Sorry. Come back over here. Does this work? No, it doesn't. I meant to put a big X on that. Okay. So think no, which is why the solution was on the other side of the line. So over here, if I plug that in over there, so X would be a 0, which is supposed to be less than 6. So 0 less than 6? Yes, it is. So therefore, the solutions to this are on the same side as the origin. And again, don't go too crazy. Just get it shaded in kind of like that. So we can still see in the background our coordinate plane. And there it is. That's our graph. So F and G are going to ask me to use my graphing calculator to graph these inequalities. And I'm just going to go through that real quick on the calculator. We're actually not going to write anything down for F or G, but I'd like you to grab your calculators, please, and follow along with what I'm doing. I'll try to get that into a space where my lighting, you can actually see it. So the first thing that we're going to do is we're going to graph it as if it was an equation. So when it comes to F, we need to do a little bit of thinking here. So if we were to solve that for y, I guess we will do a little bit on the paper here. So, but F, we'd have to think, okay, I got 4x plus 2y is less than or equal to 6. So we'd subtract 4x on both sides. Subtraction does not change the inequality, so it'll still be a less than or equal to. And then over here, that'd be a negative 4x plus 6. And then divide both sides by 2. And therefore y is less than or equal to, and this distributes to both of those. So negative 2x plus 3. So that's what I'm going to graph on my calculator. So I'm going to hit my y equals, and I'm going to put in a negative 2. Now, be careful, ladies and gentlemen. This is something that people who aren't familiar with their calculators have a little bit of trouble with. And I've tried to emphasize this a little bit here and there, that while related, there is a difference between a negative and a minus. And we see this sometimes in computers and on calculators. This is your negative key. That's your minus key. they do not work the same in the calculator. So you've got to make sure that you press your negative key for this to work. So -2, and then your variable button, x, and then +3. We can go ahead and graph that, and if need be, we can even go to zoom and make sure it's nice and standard. So mine already was set that way. So there's my boundary line right now. And I know that it's less than or equal to, so I do know it will be solid, just like it appears here. But now I need to decide, okay, which side will my solutions be on? And so unless your calculator is more sophisticated than mine is, unfortunately, we are going to have to figure that out. But again, the origin is a nice place to start. So if we go back to our original equation there, put 0 in for 4, or 0 in for 4x, so that'd be 0. Put 0 in for y, so that'd be 0. So is 0 less than or equal to 6? Yes, it is. So therefore, the solutions are going to be on the bottom side of this line. So what we do is we come back over here to y equals, and then we're going to come over to right there. So right there you can see that it's flashing on that solid line. If we hit enter, we can see that it'll change it to graphing above that line. Hit enter again, we can see it'll change to graphing below that line. And that's exactly what we want. We want the underside. So now that that's all set, y equals, and there's your graph. So the other one's a little bit easier. So if I come back over here, I can hit clear, and that'll get rid of that. And so for g, we have y is greater than 2x plus 6. So I'm going to type in my 2x plus 6. So that's all set to go. And you can graph it. All right, and it does not go through the origin, so we can use the origin as our test point. So if we plug in 0 for x and 0 for y, we're going to get 0 is greater than 0 plus 6. Well, 0 plus 6 would be 6. So is 0 greater than 6? No, it's not. So therefore, the solutions must be on the other side from the origin, meaning this time they must be going above the line. So now I'm going to go back to my y equals, come back here, and change that so it's graphing above the line. Hit graph, and that's what it should look like. So that's using your calculator. All right, so moving on to H. Write an inequality for the graphed region on each coordinate plane. So H, we can see here that our boundary is a horizontal line. So remember, horizontal lines, they always have the same y value. The y value matters. It's got to be the same y value, but the x value can be anything. So x doesn't matter. X does not have to be in the inequality in the equation. X doesn't matter. So horizontal lines are always y equals a number, or in this case, y is some sort of inequality with a number. And so what number is that? Well, it goes through +4. So I'm going to have a +4. I can tell that it's a solid line, which means it's going to be an or equal to. And so now it's just a matter of figuring out, is it less than or is it greater than? Well, I know the origin. I know the origin is a solution. So that means if I plug in 0 for x and 0 for y, specifically 0 for y, it must be true. Well, 0 would be less than 4. So this must be y is less than or equal to 4. Oh, not G. Sorry, I'm going backwards there. I. With this one, I would take a look and treat this as y equals mx plus b, so slope-intercept form. So y equals, but it's not actually going to be an equal, so I'm going to kind of leave a space there. And then we can tell here that it's going to be something x, and then the intercept is actually down, so it's going to be minus. So if we start with the intercept, we can tell it goes down to -5. So it's going to be a -5 there. Now if I look at the slope, The intercepts in particular will help me here. So I know I've got a y-intercept of -5. And then if we look for the other intercept, we can see that that's actually, the x-intercept is a +5. So that means that we must be going up 5 and right 5 as we move along. Well, up 5 and right 5 is 5 over 5 for the slope. That's a slope of 1. So 1x is really just x. So with that being said, I'm going to just slide this in a little closer. So x minus 5. Now we got to look at what kind of inequality this will be. So first of all, notice that the boundary is dashed. Because it's dashed, that tells me that it's just going to be less than or greater than. So if you think about a test point again, since the origin is one of the solutions, we know that if we plug in 0 and 0, this must be true. So 0 and 0. So 0 minus 5 would be a -5. So 0 is greater than a -5. And that's our inequality. And then the last one, J. For J, Nyla, not quite sure how to say that, but we'll go with Neela. Neela has plans to attend the school book fair and she wants to spend no more than $25. Each book series costs $15 and each book costs $5. Write an inequality to describe the total cost of the books Neela can buy and graph the inequality. So ladies and gentlemen, let's first start with, we've got series and we've got books. So the amount of money that she spends on series, let's go ahead and say that the number of series she purchases is X. We don't know what it is, so we'll make it X. So then 15X would describe how much money she's spending on all of the series she buys. Now the books, we're going to call that Y. So if they're $5 each, then 5Y describes how much she's spending on the books. Now if we add these two algebraic expressions together, then we get a new expression that tells us how money she's spent total. Now she wants to spend no more than $25. So if it's no more than, that means it could be less than or equal to $25. So there's our inequality. And now it asks us to graph it. So first of all, I'm actually going to circle that. That is my inequality that comes directly from this problem. However, I'm still going to use this, and I'm going to solve this for y just because that tends to be the easiest. We like to think about things in slope-intercept form. It's just easier. So if I subtract 15 from both sides then, I get 5y is less than or equal to a -15x plus 25. And then if we divide both sides by 5, I get y is less than or equal to, and this distributes, remember, so a -3x plus 5. Now it's time to graph. So if I graph this one out, I'm going to go ahead and go 1, 2, 3 down, and then I'm going to make that across, 1, 2, 3 down. And then I'm going to actually use the half spaces again as my single marks. So each of these tick marks will just be a single unit, so I don't really need to label that. So my boundary has a y-intercept of 5, so I'm going to come up here to 5. And then my slope is a -3, so that's a -3 over 1. So I go down 3 and right 1. So down 1, 2, 3, right 1. Down 1, 2, 3, and right 1. Down 1, 2, 3, and right 1. And that's about all I'm going to be able to fit there. Since it says or equal to, that means that this will be a solid line for my boundary. And then finally, I'm going to go ahead and shade in the solutions here. So test the origin. That's just a nice point to choose. So that's 0 and that's 0. Well, 0 times negative 3 would be 0 plus 5 would be 5. So is 0 greater than or equal to 5? Yes, it is. 0 is less than or equal to 5. So my solutions are all going to be on the left. Now this is a real world problem. So I'm actually going to have you time out for just a second here. Because one of the things that we should realize is that it would be impossible to buy a negative number of series or a negative number of books. We can buy 0 of them, but we can't really buy negative of them. And so in a problem like this, we actually are going to cut out the negative side of each axis, which means that this down here actually doesn't happen, and that up there doesn't happen. And so my solution then will be on the side of the origin, but limited to the first quadrant. So sometimes with real world problems, we've got to cut out certain values like negatives. And that, ladies and gentlemen, is the end of this lesson.